All right, let's see. Let's see where we are. Okay, so we are on 7.2 for today in this video. Only one part. Okay, so take notes. 7.2. Rational exponents. Okay, so rational exponent, what is that? Okay, so rational exponent. So first of all, hopefully you remember what a rational number is. Okay, so if you know what a rational number is, then you know what a rational exponent is. Okay, so it's basically an exponent that's a fraction. Okay. An exponent that is a rational number and that just means a fraction. Okay. So for example, you might have something like this. Okay. Your exponents are now going to be fractions. Okay, so notation and meaning. So it's basically another way to write radicals. So we just covered square roots, cube roots, and whatnot. So it's just another way to write square root, cube root, fourth root, etc. Okay, so a rational exponent a rational exponent 1 over n indicates the nth root. Okay. So if I have something like this, x to the 1 over n, then this just means the nth root of x. Okay. So for example, if I have 8 to the 1/3, this is the same thing as saying the cube root of 8. So this is the same thing as saying cube root of 8, which is going to be 2. Okay. So it's just another way to write radicals. All right, so let's take a look at evaluating. Okay, so suppose I have this 9 to the 1/2. Okay, so again, that is like saying the square root. Okay, so this is like saying the square root of 9. So that's just going to be 3. Okay. If I have this negative 64 raised to the 1/3. Okay, so 1/3 is the cube root. Okay, so that is cube root of negative 64. So that would be negative 4. Let me box my answers. Okay. And if I have 16 to the 1/4, that is the same thing as saying the fourth root of 16. And that would be 2, because 2 to the 4th power, 2 times 2, 4 times 2 is 8 times 2 is 16. 2 to the 4th power is 16. Okay. And then if I have this, negative 1 over 32 to the 1/5 power, then that would be like negative and then the 5th root of 1 over 32. Okay, so that's going to be negative, and the 5th root of 1 is 1. The 5th root of 32 is 2. So negative 1/2. Okay. here we just dealt with numbers. Let's throw in some letters, some variables. So let's take a look at evaluating these. All right, suppose that I have this. Suppose I have y plus 4 squared raised to the 1/2. Okay. So this is like saying the square root of y plus 4 squared. Okay. And so it's like the square and the square root cancel, and we're left with y plus 4. But don't forget, since we're doing square roots, we do need the absolute value. Okay. Suppose that I have this one, 25 b to the 4th, everything raised to the 1/2. Okay, so that 1/2 again is the square root. So if you want to rewrite it as the square root of 25b to the 4th, then the square root of 25 is 5. And if you want to rewrite this as something squared, that would have to be b squared to make 4. So we have b squared. Even though we're doing square root, we don't need to do absolute value because we have right in here, this is already going to be positive. B squared is positive, so we can ignore the absolute value symbols. Okay, if I have this one, negative 256 to the 1/4, that's like saying the 4th root of this negative number, which we said is not real. Okay, so we don't want to take even roots. We don't want to do even roots of a negative number because then we get imaginary. Okay, let's take a look at this one. Negative 27 x cubed raised to the 1/3. Okay, so this means cube root. Cube root of negative 27 x cubed. Cube root of negative 27 is negative 3. And then cube root of x cubed is x. And since this is cube root, we don't need absolute value. Okay. And suppose that I have this 256 a to the 8th to the 1/8 power. Okay. So again, that's like saying the 8th root, right? Whenever you have this fraction, it's a root. Okay. So 1/8 means 8th root. 1/3 means cube root. 1/4 means 4th root. Okay. So this means the 8th root of all of this. 256a8. 8th root of 256 is 2. And then 8th root of a8 is a. But we do have even root. This is an even root. So we do need the absolute value. Okay. All right. Excellent. So that's how you evaluate them. So let's take a look at what happens if we don't have a 1 here. Like say we have like 2/3. Okay. So we know right now that these all mean like square root, 4th root, cube root, 8th root. Okay. So let's take a look at simplifying. A to the m over n. Okay. So note a to the m over n is the same thing as doing the nth root. Okay, so nth root of that, and then raising it to the m power. Okay, so when you look at this, it's basically this number here in the denominator represents the root, the radical, right? And then up here, this represents the power like you as you know it. Okay, so here it acts like the exponent that you're familiar with. Okay, so let's take a look at an example here. So if I have 8 to the 2/3, so here, again, this bottom number is like the root. So that's like cube root of 8, right? So that's like saying cube root of 8, and then we can pull that power out, okay? Because remember, with rules of exponents, we would multiply power to a power, we would multiply these. 2 times 1, and then you have this over 1. 1 times 3. 2 times 1, 1 times 3. Okay, so that's 2 times 1, 1 times 3 is 2/3. So these are equivalent. Having your exponent written like this versus like this. Okay, so you can write it as 1/3 and pull that 2 out. Okay, and so here, this is like saying the cube root of 8. And the cube root of 8 is 2. And so we get 4 for our answer. Okay. All right, so let's go ahead and try some. So let's go ahead and evaluate these. Let's go ahead and try this one. 32 to the 2/5. Okay, so 32 to the 2/5. Okay, so first of all, that's like 32 to the 5th root of 32, and then squared. Okay, so that's like the 5th root of 32, and then whatever we get, we're going to square it. 5th root of 32 is 2, and then we're going to square that, and we get 4. Okay, let's take a look at another one. 81 to the 3/4. Okay, so we're going to pull out that 1/4, and we'll put that 3 on the outside. Okay, so now that tells me that this tells me I'm taking the 4th root of 81, right? So let's go ahead and write that 4th root of 81, and then we're going to cube our answer. So the 4th root of 81 is 3, and then to the 3rd power, 27. Okay, see how we're doing that? So it's like we pull the 2 outside, we pull the 3 outside. Okay, and then you can work with the radicals on this inside base here. All right, let's take a look at this one. Negative 64 to the 2/3 power. Okay, so it's negative 64. I better use another set of parentheses. To the 1/3. And we'll pull the 2 out here. Okay, so that means the cube root, right? So that's the cube root of negative 64 raised to the 2nd power. Cube root of negative 64 is negative 4 squared. Negative 4 squared is 16. And let's do this one. Negative 1 over 25 to the 3/2. Okay, so that negative number is not part of our base. So this negative number will be multiplied at the end, because order of operations, you do exponents first and then you multiply. Okay, so that will hang around out there. And it's 1 over 25 to the 1/2 power, and then cubed. Okay, so that's like saying the square root of 1 over 25 to the 3rd power. Okay, square root of 1 is 1. Square root of 25 is 5. And then we're going to raise that to the 3rd power. So we get negative 1 over 125. Okay, so that's how you evaluate these if you don't have a 1 above it. Just remember that bottom number represents the root that you're going to be doing. So that's going to be square root, which we see here. That's going to be cube root, which we see here. That's going to be fourth root, which we see here. And this is the fifth root, which we see here. Okay? And these top numbers represent the exponent as you know it. So it's going to be your answer squared, your answer cubed, your answer squared, your answer cubed. Okay? All right, let's take a look at some that have numbers and variables. All right, so let's simplify these. And I'm going to make a statement here. All variables are positive and real. Okay, that way when you see a statement like this, you don't have to worry about your absolute value symbols. Okay, so you can ignore all of your absolute value symbols because we're saying all the variables are positive. Okay, let's take a look at this first one. 36 m to the fourth raised to the 3 halves. Okay, so again, this means you're doing the square root of this 36m4. Okay, so I'm just going to go straight to the square root, 36m4, and that cubed is going to be out there, right? Okay, so here, the square root of 36 is 6, and then here, the square root of m to the fourth. If you're trying to figure out what's being squared here, so that's got to be a 2, okay? All right, so square root of 36 is 6, and then m squared is being squared, and then we're going to go ahead and cube that. So when we cube that, 6 times 6 times 6 is 216, and then right here, rules of exponents, you multiply the exponents, so we get 6m to the 6th. Okay, let's take a look at another one. Negative 8 x cubed raised to the 4/3. Okay, so again, this means cube root. So we're going to be taking the cube root of this and then raising our answer to the 4th power. All right, so let's just go ahead and go straight to cube root of this and then raising our answer to the 4th power. All right, cube root of negative 8 is negative 2. Cube root of x cubed is x. Now we're going to raise that to the 4th power. Negative 2 times negative 2 times negative 2 times negative 2 is 16. And then that's x to the 4th. Okay. And let's do one more here. Negative. And then we'll do x to the 5th, y to the 5th, to the 2/5. Okay. So again, this means we're going to do the 5th root of this here. And then our answer, we'll raise it to the 2nd power. This, in the meantime, will hang out there. So we're doing 5th root of x5, y5. And that answer, don't include the negative. That negative goes last. That answer will be squared. All right, so negative. And so the 5th root of x5, y5 is just xy. And then we're going to go ahead and square that. And then multiply it by negative. So that we get negative x squared, y squared. Okay? All right, so that's how you simplify those. Just a little note about your rules of exponents. They still apply. Okay, so let's just do a little note here. exponent rules still apply. Okay, so if you are multiplying like bases, you add the exponents, right? If you're dividing like bases, you subtract the exponents, right? And if you have, and we just saw this, if you have power to a power, then you multiply the exponents, right? The only difference now is that you're going to have to do these operations, addition, subtraction, and multiplication. You're going to have to do that with fractions now instead of integers. Okay, so here, let me give you an example. Let's do one. Let's do one where we're multiplying like bases and their fraction exponents. Okay, which means we're going to have to add them. Okay, so let's take a look. Suppose that I have this 5 to the 2/3, 5 to the 3/4. Okay, like bases, so I have to add the exponents, right? Before, when you had this, right? Here, let me do. When you had this, when you had just regular integers, well, that was easy to do. We can add 2 and 5 in our heads and we get 5 to the 7th, right? Now you have to do some work off to the side because we can't do 2/3 plus 3/4 in our heads. Okay, so this is going to be 5 to the, and we know we have to do 2/3 plus 3/4. We don't know what that is in our heads. So much nicer back in the good old days, right? When you have these. All right, let me erase this. All right, so off to the side to do the work because we can't add fractions in our heads. 2/3 plus 3/4. Maybe some of you guys can. All right, so if you remember, we need common denominator. Common denominator between 3 and 4 is 12. So I need to make these fractions look, denominators look like 12. So then that means I have to multiply that 3 by 4, but then also here, multiply this one by 3 and up here by 3. Okay. All right, so then that becomes 8 over 12, and that becomes 9 over 12. And then now I can add them. 9 plus 8 is 17. Okay, so this is going to be 5 to the 17 over 12. Okay, and then you would just leave it like that. Okay, so just keep that in mind. If you have, same thing here, if you have this, then you have to do subtraction, and you would have to do this where you have to get the common denominator. And then if you have, let's do this same problem, but let's make it this last example. Okay, so suppose you have 5 2/3 raised to the 3/4. Okay, so according to our rules, we would just multiply these exponents, right? So that would be 5 to the 2/3 times 3/4. And if you can cross cancel, go ahead and do so. 3 and 3 cancel. 2 goes here once, 2 goes here twice. So then I'm left with 5 to the, across the top, I get 1 times 1. And across the bottom, I get 1 times 2. So that's what you would have. Okay. All right. So that, I believe, is it for 7.2. And so the next video will be 7.3. Again, text me if you have any questions.